Here are quiz solutions for quiz 2 for Math 60. In the first problem, we're given three different numbers and asked to find each of their prime factorizations. So the basic idea here is you can kind of create these factor trees. And to create a tree, you just need to find two numbers, any two numbers that multiply together to give you 35. Any except for 1, I guess. You wouldn't want to write 1 times 35 here. You wouldn't really get anywhere. So 35 ends in a 5. So 5 times something gives me 35, in this case 7. And for this problem, we can't go any further because these are both prime numbers. So what we get is that 35 is equal to 5 times 7. In other words, its prime factorization is just 5 times 7. And that's it. That's all you do. For 120, it's a little bit trickier because you start out with the same method making this tree. But what you'll see is our tree will have more branches than it did up here. Let's see, 120, it ends in a 0, so it's divisible by 10. So one way to split it up would be 12 times 10. 12, I don't know, it's 4 times 3. Could also say 2 times 6. Doesn't matter, you'll get the exact same answer. 4 is 2 times 2. And 10 is 2 times 5. And at this point, everything at the bottom of my tree here, or at the end of my branches, however you're viewing this, are prime numbers. So we're as far as we can go. We got that 120 is equal to, what, 2 times 2 times 2? You could write 2 cubed, but since we haven't gone over exponents yet, I'll leave it like this. Times 3 for this 3 right here. Times 5 for this 5 over here. And that gets us sort of all of our prime numbers here. So the prime factorization of 120 is 2 times 2 times 2 times 3 times 5. 72. A couple of different ways you could break this one up. One way is 7 plus 2 is 9. And so because 9 is divisible by 9, this thing must be divisible by 9. There's this cool little trick with 3's and 9's that if you add up the digits, it can tell you divisibility. So in this case, 72 is 9 times something. That something is 8. And 9 is 3 times 3. Whereas 8 is 2 times 2 times 2. So we get 72 is equal to, looks like I got 3 of these 2's, 2 cubed, which you can write as 2 times 2 times 2. And then I got 2 of these 3's, so 3 times 3. This right here is my prime factorization for 72. And that's the end of the first problem. The second problem kind of has you use that stuff that you just figured out. So what it wants me to do is multiply together these two fractions. And the way it wants me to do it is by using those prime factorizations I got from above. So earlier I found out that 35 was 5 times 7. And 120 was 2 times 2 times 2 times 3 times 5. And I want to multiply that by 72, which I figured out was 2 times 2 times 2 times 3 times 3 divided by 7, which is a prime number, so it is its own prime factorization. And the nice little trick with these, when you're multiplying fractions, you can kind of think about it all as one big fraction. It's really just all these numbers divided by all these numbers, which brings you to the kind of satisfying step where you get to cancel stuff out. I got a 5 on the top and a 5 on the bottom, so I can cancel those out. I got a 7 on the top and a 7 on the bottom, so I cancel those out. 2 on the bottom, 2 on the top. Another 2 on the bottom, another 2 on the top. Another 2 on the top, another 2 on the bottom. 3 on the bottom, 3 on the top. Looks like everything from the bottom canceled out, and I was left with just a 3 on the top. So your final answer, you could write 3 over 1, although typically when you have a fraction and you have 1 as the denominator, you don't even write it, you just write 3. So I would say that our final answer is just 3. The next problem looks a little bit harder. Turn out it's a little bit easier. We are dividing fractions. The way you divide fractions is by saying you hate dividing fractions and you'd rather multiply fractions. Well, dividing fractions is just like multiplying fractions, except you multiply by the reciprocal of the denominator. All that means is you flip this number right here upside down. You say that instead of division, I can make it multiplication, if instead of dividing by 7/72, I multiply by 72/7. So what I've managed to do is change this division problem into a multiplication problem. And we know how to do multiplication problems. You find all the prime factorizations, you cancel out everything you can. If you're really clever, you'll note, this is exactly the same question as 2a. All right, 35 divided by 120 times 72/7. That's exactly what I have here. So the answer is the same. So it equals 3. If you didn't notice that, you could go through these exact same steps, right? All the prime factorizations, cancel everything out, you'll get the exact same number. But to save time, I'll just say, no point doing the exact same thing again, same answer. All right, now we're left with adding and subtracting fractions. Unfortunately, I made it hard. I didn't give you a common denominator. These are a lot easier when you have a common denominator, but I didn't give you a common denominator. I'm mean like that. So what we'll have to do is find the least common denominator and then add or subtract the fractions. And the way we'll do that is by finding the prime factorizations. The prime factorization for 18, actually, have we seen that one before? I guess not. I thought that was one of these. So for 18, well, let's see, that's 6 times 3, I guess would be one way we could do it, and 6 is 3 times 2. So really 18 is just 2 times 3 times 3. And similarly 12, I don't know, 4 times 3, or 2 times 6 if you prefer. Either way, you'll end up with 12 being 2 times 2 times 3. So the least common denominator is, we gotta look at 18 and 12 and come up with a set of numbers that will have all of these parts. It'll have enough parts to build a 2 and a 2 and a 3 from it, or if we wanted to build a 2, a 3, and a 3 from it. So first let's just look at 2's. We're gonna need at least 2 2's. We need 1 for this guy, but we need 2 for this guy. So we'll need 2 different 2's. And then 3's, we need 1 for this, but we need 2 up here. So we'll need 2 3's. So 2 times 2 times 3 times 3, if you multiply those all out, you get 36. That's our least common denominator. Note that right here, 2 times 2 times 3, we have 12. And over here, 2 times 3 times 3, we have 18. Here's our least common denominator, it's 36. So with that knowledge, we can go up here and do these problems. We can say, all right, I have 11 over 18. How should I write that? All right, 18 is 2 times 3 times 3. I'll use all the work that I've done. And from that, I want to subtract 5 over 12, 12 being 2 times 2 times 3. And the way I'm going to do this problem is I'm going to make these denominators both be equal to my least common denominator. So if you look over here, I have 2 times 3 times 3. I want 2 times 2 times 3 times 3. I need another 2. The way I can get another 2 in the denominator is by multiplying this fraction by 2 over 2. Multiply the top by 2 and the bottom by 2 so that you don't change the value of the fraction. Same idea over here, multiply the top by 3 and the bottom by 3. I now have the same least common denominator, but I haven't changed the value of this fraction. So what I have is 2 times 11 is 22. And down on the bottom I have 2 times 2 times 3 times 3, which I know is 36. And over here I got 15 divided by 2 times 2 times 3, blah, 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 36. 22 minus 15 is 7. I have 7 36ths. You should check to make sure that doesn't reduce. In this case it won't, because 36 is just 2 times 2 times 3 times 3. It doesn't have any 7's in it. 7's a prime number. So we can't reduce this fraction at all. We're all done. Adding fractions. This order is kind of weird. You would have thought I'd put this as part C and this as part D, but for some reason I didn't. Part D will be a lot easier if you've done part C, because really the steps are the same. We want to find the least common denominator. Well, it's the same numbers in the denominator, so it's still 36. Same numbers even in the numerator. So what we'll get is 2 times, all this work will be the exact same. The only thing that will change is this will be a plus sign. In other words, what we're going to have, maybe I should switch colors. Everything will be identical until we get to this stage where we have 22 36ths and 15/36. The difference this time is instead of subtracting them, we're adding them. Okay, if you're adding fractions and you have a common denominator, leave the denominator alone, add the numerators. 22 plus 15 is 37. 37/36 is our final answer. Maybe I'll even write same numbers as part C. So, ... We do all this part the exact same and get this as our answer. So that's the final answer. I guess that's the end of this quiz.